And so this is organized chaos. This is the evolution of the web from its start in 1991 all the way to the current time, focusing on how we built the web. And the thing about the web, which is I find genuinely really fascinating, is that is that it is simply the most impactful technology we as humanity have ever constructed. Human civilization has existed for about 20,000 years. The web has existed for about 30 years. And the web has completely changed the way that we interact with other people. And this wildly powerful impact was not designed. There was a couple of people that had good predictions, but no one was exactly right. And the people who originally tried to construct the web really didn't even know what they had until it was already evolved to something else. So the web really had its start in 1991. Your computer would have looked like this. More likely or not, you would have been at a university because where personal computers existed, they were really expensive. So you were more likely going to be at a university, especially if you had an internet connection at the time. You were probably at a university in order to do that connection. And at the time, there was a really early version of Reddit called news groups. That was how you communicated with other people across the internet. And you would use a specialized protocol. You go onto your terminal. You'd be able to search the groups. There was different topics. And there was one topic called hyperlinks. At this time, the idea of creating connected documents existed for about 20, 30 years. But no one really put together the idea of trying to build some sort of hyperlink system that would span the entire globe. And so we get this message in that hyperlink news group, where somebody asked if anyone is aware of someone trying to build this kind of hyperlink system, in which someone responded that they are constructing a project called the World Wide Web. And this is the first time the term World Wide Web is used publicly to describe the project. This post was written by Tim Berners-Lee. And pretty much was him just sort of announcing or letting him know that he was working with a bunch of high energy physicists to be able to exchange information. And I find this sort of emphasizes sort of the how humble the web is as a concept, is that this wasn't a grand announcement. This wasn't we're changing the world. This is, hey, I have this project I'm working on the side here that'll help some very niche group of people, and we're open to collaborators. And this notion of collaboration stems through the entire process of building the web, and what made the web more competitive compared to a lot of other solutions like Gopher or, mainly Gopher, that was trying to compete with this kind of a concept. One other big thing to keep in mind is that the World Wide Web and the internet are two separate things. And not just are they separate things, but there's a solid 22-year gap between when the internet started and when the World Wide Web started. And to really understand the World Wide Web, you have to understand where the internet was at the time that the World Wide Web started. And to do that, we have to jump all the way back to 1969 with ARPANET. So ARPANET was the progenitor of the internet, and it was created by the Department of Defense to make it easier for different universities to communicate with each other. So at this point, we had computers the size of rooms. They were coming down to the size of large cabinets. And computers are starting to be used across different universities. However, these computers were made by different manufacturers that had different protocols that communicated in different ways. And it made it hard to share research data, which slowed down the progress of research for the Department of Defense. So they're like, hey, why don't we make an internet, United States-wide network that's standardized so that we can exchange information. From there, 2 years later, we get the first email that is sent over this internet. A couple years later, we get our first personal computers, 14 years before the web got announced. We get Windows 1.0, so the first GUI interface, 6 years before that web was announced. We also, very interestingly, already have domain names by the time that the web is introduced. Because at this point, people were communicating over the internet, and you needed a simpler way to be able to address specific people or specific universities. So we came up with a domain name system and domain names to be able to manage that. And then, more importantly, in 1989, Taylor Swift was born. So
What a cute baby.
yeah, what a cute baby. So the web, it's kind of crazy to think about that the web is younger than Taylor Swift. And so this brings us back to 1991 and that announcement. So we already have domain names. We already have the internet. Internet's already pretty popular around universities and is being actively used by the time the World Wide Web, but it's a bit chaotic. Now, this announcement came out of CERN, which is well known for the Large Hadron Collider and is a center for nuclear research out in Europe. And the person who made this announcement, Tim Berners-Lee, was a technical IT consultant with CERN, helping them manage their information systems. And 2 years before this announcement, Tim Berners-Lee made this proposal to his manager, Information Management a Proposal, where he outlined this hypothetical system that will allow distributed access of information. And in particular, the problem that he was looking to solve with this system was that CERN was turning over people every 2 years. So CERN, the way CERN is structured, they bring in scientists, they leave after 2 years. And because of this, departments change every 2 years, information change every 2 years, projects change every 2 years, and it was a chaotic mess, and it was really hard for them to keep track of what was happening at CERN. So he was posing this idea of creating a distributed system with documents that interlinked between each other that each department could manage on their own to make it easier. Because before this, they had internet systems to be able to keep track of things, but it was very centralized, very difficult to manage. And you had to have one person that knew the system really well to be able to update and manage it. So by distributing it and making it easier to access, it made it so they could keep this information updated. And so his proposal is using hypertext, which at this time existed in the mind space. Tim Berners-Lee himself made local hypertext projects. There was something called Note Card, something to that effect, which allowed you to be able to use hypertext locally on a computer, but no one really quite figured out how to do it across the internet. And what I find really interesting about this proposal is how much it still carries over to today. So his hypothetical system has clients that reach out to servers to receive documents. This is still how the World Wide Web fundamentally works today. So Tim Berners-Lee constructed this baseline in 1989 that we still use today, that still has evolved today, which sort of shows sort of like the foresight and like understanding the problem that he was trying to solve. So 2 years later, he makes the first website, info.cern.ch, which was primarily just a website to tell you how to build websites. And then in 1991, he produces another really big accomplishment. So to understand this accomplishment, you first have to really understand the internet. So the internet and the internet protocol, the way that it's designed is you can sort of think of it as like a post office and sort of like the envelope around a message. All the internet does is make it so you can send a message from one computer anywhere in the world to another computer anywhere in the world. However, what was up to the engineers was to design an application protocol. And the application protocol you can think of is how do you structure the actual letter? You can send whatever you want, but you need a standardized way to do it. And at this time in the internet, there was a ton of different protocols, and each of these protocols were hyper-specialized to solve a very particular task. So when Tim Berners-Lee was sitting down to build this system, he needed to figure out how to build a protocol that works really well for his new World Wide Web. So he came up with the HTTP protocol, or the Hypertext Transfer Protocol. And the Hypertext Transfer Protocol, part of its success comes from how bloody simple it is that this is a request response. A request has three parts: a verb, which says what you want to do, so create a document, fetch a document, delete a document; headers, which is just metadata that the sender or receiver can agree on; and data, which is optional on requests, that just send over whatever data you want to send over to the server. And the response, almost the same thing, but instead of a verb, you have a status code, which says what this condition of the request is. So you can have 200, which is a success, or 404 means that you requested a document that just doesn't exist. And by it being so simple, it allowed very easy transfer of information that was standardized across systems. And even though it's a hypertext transfer protocol, this protocol, because it has just an open data field that you can store any kind of data, it can transmit anything, including images, scripts, videos. 1 year later, in 1992, we now have the protocol to be able to actually transmit information, but we needed a standardized way to be able to address specific documents. Because we're building a universal document system, we need to make sure that we have a way to address a document that is durable. That is, that if I give you a link or some sort of reference to that document, I'm sure that when you open it, we're going to look at the same document. And this is a bit tricky because we have to deal with a world scale system. And that in certain domains might have multiple kinds of documents. There might be multiple ways you want to fetch documents. So Tim Berners-Lee came up with the Uniform Resource Locator, or URL, which the idea with the URL was just to sort of list out all the sort of parameters in order of how to retrieve a document. So it starts with the protocol you use, so most often HTTP or now HTTPS, but you can also do a file transfer to just transfer files, so FTP is another popular one you can have there. And there's a couple other ones you might still see on the web. Mainly now it's just HTTP. You have the domain, which comes from the domain name system that already existed for 6 years before this came out. You would then have a path, which is essentially, you can think of it as like a file system. The path is arbitrary, technically speaking. But it's what it allows you to do is be able to organize things like a file system, which helps people conceptualize how these documents are organized. And then you have an optional query string, which consists of a series of key value pairs that you can use to do optional querying of data. So let's say you're going to a document collection instead of a single document, you can add queries to figure out, retrieve a list of documents instead of a single document. Exactly how we use it today. HTTP URL, fundamentally unchanged in 30 years. Then we get the next big thing, which is HTML. So now we have to find the document. We now know how to send the documents. Now we need the documents themselves. And so we come up with HTML, which comes out from earlier SGML, which is an earlier markup language, which itself was from an earlier markup language. But the idea of HTML is just a way to organize documents. And how it works fundamentally is, let's say you have a document that says like this, that's just about bunnies. This document by itself isn't super useful because it's hard to understand the meaning of different elements of the document. So we can make this more useful by adding tags to different things. So we have a header tag, an H1 tag onto the bunny, so that's the header of the document. Then we have different paragraphs. We can add an anchor or a link that allow you to link to something else. So let's say we want it, so carrots links to a document about carrots. We can add the URL to that thing. And then what will happen is on our web browser, we can generate this kind of a structure, so that it makes it easy to consume documents, easy to produce documents, and that these documents are interlinked, and then you can do something crazy. You can click on carrots, and it pulls up another document, which at the time was really novel, but really made it easier to access information and interconnect information. And this is the first publication of the HTML specification, and I use specification in the loosest possible terms. This is more Tim Berners-Lee just ranting about what he thinks HTML should be. It's not all that long and consists of 27 different tags, of which only 16 of them survive to the modern day. But this tells us a lot about sort of the mindset of the people at the time, is that they were seeing this as much more of a traditional sense of a typewriter or information exchange system. So you have a typewriter tag to issue typewriter text or text only going to typewriters, as well as index and listing, with the idea of this being more navigationally focused. But one omission from this list, which we'll get back to in a second, is there's no image tag. The first start of the internet, there's no such thing as images. Cool. So now we have URLs, HTTP, HTML. And then we go to Illinois, middle of nowhere, Illinois, at the NCSA, or the National Center for Supercomputing Applications. And there's an undergrad there named Mark Andreessen who sees Tim Berners-Lee's messages and sees the conversations that are happening about the web. And is like, well, it would be really cool. What if I built a web browser? This was an undergrad, just as a side project, not their main thing. And he constructs Mosaic, which is the first widely popular web browser. And what made Mosaic different than every other web browser at the time is that it was usable. He built a web browser for normal people and not other engineers or nerds. Every other web browser, including the web browsers that Tim Berners-Lee made himself, were all had the idea that you were an engineer. Mosaic was for people that weren't engineers, and it became widely popular. But something interesting about Mosaic is it introduced the image tag. It shipped originally with the image tag. And this was, in of itself, a small controversy at the time. And there's this really fun exchange that happens where Mark Andreessen says he wants to propose a new tag called the image tag, which allows you to load an image onto a web page. And that he wants people to let him know what they think about it. Now, this is a very polite way to ask for their thoughts, but in reality, by the time he made this post, he already built the image tag, was already in the Mosaic browser, and it already shipped. Mark Andreessen could care less about what other people thought about the image tag, including Tim Berners-Lee, who hated the idea. Tim Berners-Lee did not want images on the web. And the reason he didn't want images on the web is he thought of it as like an academic system, like you're exchanging academic papers. And he was nervous that by adding images, it would sort of decrease the value of the web by making it more chaotic, by like making it more commercial, and it would move away from the ideal of information exchange. And instead, Tim Berners-Lee wanted a figure tag that was allowing you to make an academic style figure in a page. And he, say again?
Which we have now.
Which we have now. Yeah, we do have the figure tag now. So eventually it comes back around. But what's really, I think this one line makes me pretty funny, is that he'd rather not have an image tag. And to understand the situation, you have an undergrad at a random university in the middle of Illinois talking to Tim Berners-Lee, who is like a seasoned engineer, incredibly strong pedigree background, and the undergrad wins. The undergrad says there's going to be an image tag, therefore there's an image tag. And it sort of shows like this evolution of the web really does come from random people in random places that just are in the right place at the right time that have the good ideas. Even though Mark Andreessen did not have the same kind of pedigree as Tim Berners-Lee, Mark Andreessen had the right idea when he built the browser, had the right idea when he had the image tag. And so Mark Andreessen, a year later, Mosaic becomes widely popular. And NCSA sees the side project and realizes, oh crap, we have something meaningful on our hands. And they push Mark Andreessen inside because he was an undergrad, being like, we'll bring in the real engineers now, Mark. You can go and do whatever you want to do as an undergrad. This was about the time he was looking to graduate anyways, so he was taken off the Mosaic project. Around the same time, a gentleman by the name of James Clark, who made the first CGI company, was looking for a new company to start, saw Mosaic become really popular, and like, hey, there could be money here. So he goes to Mark Andreessen and a bunch of his friends, convinces them to go with him out to California to start a new company called Netscape, building a new browser called Netscape Navigator, which takes the same concepts of Mosaic, but makes it in more of a commercial, much more scalable fashion. And very quickly, Netscape sort of takes over the scene. Now, at this point, we have HTML, which allows us to be able to structure documents, but the internet's ugly. And this is a fun exchange. Essentially, this is Mark Andreessen talking to one of his colleagues, pretty much telling them that they're screwed if they want to do anything more than lay out information. And what was really painful about this is that there was already other kinds of systems that allowed you to do interesting and pretty documents, but the web didn't have this. So the web needed styles, and it needed a way to design documents. Around the same time, Tim Berners-Lee left CERN. His tenure at CERN went up, moved to Boston and MIT, and founded the W3C, the World Wide Web Consortium. And the point of the World Wide Web Consortium is Tim Berners-Lee realized how absolutely chaotic the evolution of the web is at this point. So he wanted to try to bring in some order to this chaos by having an organization that manages specifications and helps guide the web to where it's supposed to be. And one of the early collaborators in the Worldwide W3C was Hakon, who created CSS, or cascading style sheets. So there's a couple of different proposals to be able to like stylize the web. But this particular proposal is what ended up going through, and part of the reason is for its flexibility with HTML. So how CSS works is that, let's say we want to style this document. The first way we attempted to style this document was by adding more and more and more tags onto the document to be able to change the color, change the styles, change the font, and we can get like this pretty little thing with italics and colors. But like you can see very quickly, even with this small example, that this is becoming unmanageable. Imagine you have a really complicated website and you're using tags to style. It will be near impossible to manage that. Never mind if a designer comes in and is like, okay, can you change this color? It's like, good luck trying to figure out all the tags you have to adjust. So instead, the idea is that instead of putting the style into the tags, we create separate style sheets or definitions of styles, and we attach them to those tags. And now those tags will be styled in the same way as before, but it's way more manageable. And what this allows us to do as well is it allows our styles to be very adjustable. So let's say we want to change the color of the text to yellow. We change it in that one spot, and because the references are everywhere in the HTML, it will automatically update our HTML. So it makes the styling much more manageable than just adding it into the tags. And the cascading comes from the fact that these sheets also mix together and cascade together. So if you style a parent element, all the children element will get the same styles, and you could overwrite it if you wanted the child, but it makes it very manageable to do styles efficiently across an entire website. So this makes the web way easier to work with, way prettier to work with. Now, elsewhere in the middle of Washington, a small man by Bill Gates, who runs a small company called Microsoft, starts to hear about the web and is utterly terrified about the prospect of the web. And he releases this memo called the Internet Tidal Wave, which is a really long memo, where he pretty much says that if Microsoft doesn't move quickly, the web is going to bankrupt the company. And the big thing that Bill Gates was seeing was the web was a platform for people to interact with applications, which is what the operating system was supposed to do. In other words, he saw that the web continued developing and Microsoft wasn't ahead of it. It would render the operating system useless. So in this Internet Tidal Wave, he states that Microsoft's highest priority is now going to be the internet and the web. And that he thinks it is the most important development since the personal computer in 1981. In particular, he credits the HTTP protocol and HTML as being what makes the web actually useful and actually dangerous to Microsoft. And then he also makes a very fun note where he is genuinely surprised that the web exists at all, because Microsoft's been trying to do this for probably decades now and wasn't able to manage to build this kind of system. But a bunch of random people scattered around the world managed to build a better system than one of the wealthiest companies in the world, which again shows to how crazy this idea of the web is on the way that it was developed. So, Bill Gates' solution: go to NCSA and grab the source code for Mosaic and turn it into Internet Explorer. Which, mind you, at the time Mosaic was showing its age because the real engineers managed to not do any proper improvements to it. So when they were building Internet Explorer, they were building it already off of a bad browser, and then they didn't have engineers working on Internet Explorer that really fully understood yet the internet, because they weren't really collaborating with the rest of the community. So you get a pretty mediocre result out of Internet Explorer, but for Microsoft, it did the job. It connected the web pages. But the other big thing that Microsoft did is Microsoft threw in IBM and other computer manufacturers to not include Netscape as default on computers. And this was a huge problem for Netscape, because at the time, there's no web to download things with. If you got Netscape on your computer, you either had to buy it as a CD, or you had to go through the incredibly difficult process of navigating the web to download it, which is something that common people would never do. And so by blocking them from allowing Netscape on the browser, it put Netscape in a really awkward position. So Netscape, seeing the specter of Microsoft, had to try to innovate fast, to try to outpace Microsoft with the hope if their browser is just that much better, they could maybe stay in the game. So one of the first things they needed to figure out how to do was make the web interactable. So we have structure, we have style, but right now these web pages can't do anything. They're just information systems. So they want to hedge their bets because they don't have time with Microsoft breathing down. So they first go to Sun Microsystems into their brand new operating system at the time, Java, and say, you are going to be the language of the internet. You're going to be what people build, do interactions with the internet. You're going to be embedded into our browser. At the exact same time, they go to a man named Brendan Eich and say, hey, we want, Java is great and all, but it's only good for engineers. We want like a hobbyist language to go alongside Java just to help people do like tanker projects and assist in Java. And also you have 10 days. So in 10 days, Brendan Eich creates a language, and when he creates it, he has to make it as minimal as possible, as simple as possible, to make it so that he can deliver on time. And also, it's only supposed to be like a toy language, so it doesn't need to be that robust. So he creates Mocha, which they then renamed to LiveScript, which they then renamed to JavaScript. And a part of the name JavaScript comes from this idea that it is a smaller version of Java that works alongside Java, and also Java was getting really popular and they wanted to capitalize on that. And now we have the core foundational technology of the internet in 1995. So these are the base of the internet, which we still use today. So another problem we're starting to get with the web is that if you wanted to build a web page that was a store where you had different users, you had to build HTML for every single user. And that means a million different HTML pages. You don't have enough engineers. So we needed to start developing technologies to help be able to build pages for the masses. And this is where PHP comes in, or personal homepage, or later renamed to PHP Hypertext Preprocessor. And all PHP allows you to do is be able to automatically create HTML pages, but on the server, by embedding code into the HTML itself. So let's say I want to have this kind of a page that says hello Brian or hello client. I can add this special PHP tag. I can add code into there that might fetch the user's name and then display it on there. This PHP would then be processed on the server into this HTML, which would be then sent to the client. And this allowed for much more dynamic pages, much more dynamic experiences. It allowed you to actually build a large-scale platforms on the web. In 1996, Microsoft sees how good JavaScript is doing, and so they create their own language called JScript, where they just reverse engineer JavaScript and then just shove it into Internet Explorer. And the most painful aspect is they did not copy it entirely. They copied most of it. But the end result means that now, if you were building websites, you would have to worry about whether your user was on Internet Explorer or on Netscape, because your code would not work the same across both of them, and it would create a lot of hassle. And at this point in the web, you saw banners on websites being best viewed in Internet Explorer, best viewed in Netscape, because of just how chaotic these two languages were. Also in 1996, it became very evident that both JavaScript and Java were very slow. Java was particularly slow because when you viewed Java on a website, you had to download the entire Java virtual machine to run Java. And that was hard to download. There was issues with version control. On top of that, Java gave you complete access to the computer. So essentially, this was like a hacker's paradise. They could do whatever they wanted when they go onto that website, which is terrifying. And also, Java was full of bugs. It was hard to build. It was really temperamental. It was painful to work with. JavaScript, on the other hand, was incredibly immature. It was a toy language. It didn't allow you to do full function stuff on the web. So the result is that it was hard to do really interesting things on the web. So here comes Flash. So a company builds Flash to make it so that we can do animations, interactions, pretty much do everything that JavaScript and Java was supposed to allow us to do. And the way that Flash works is you would install a plugin onto your browser, and it would render all the Flash content as Flash. And if you didn't have Flash, it would redirect you to download Flash and install it on your browser. So now Netscape sees JScript, is okay, we need to get this situation under control. We want to standardize. So they go to the W3C and be like, do you want to standardize JavaScript? And which the W3C said no. W3C didn't want to standardize JavaScript because they felt like JavaScript was going in the wrong direction because they wanted a web that was much more predictable. When you start introducing programming languages and dynamic content like that, it makes the web pages less predictable, it makes things more chaotic, and W3C wanted things to be standardized and less chaotic. So instead, Netscape went to ECMA, which is a European standardization organization, who picked up JavaScript and 1 year later renamed it yet again to ECMAScript. And this is just the formal standard of JavaScript, which if you haven't noticed is now the fourth name for JavaScript, not including JScript. A year later, Netscape is clearly losing the browser war, so in a ditch effort to try to stay relevant, they open source their code. At the same year, Microsoft realizes they won the browser war and pretty much tell the W3C that they're not going to participate anymore. The W3C can still do standards, and Microsoft will take whatever standards they want. They'll also do whatever they want because, what is W3C going to do? So W3C, realizing they can't do anything on the browser side anymore, focuses now towards server-to-server back-end communication. And the first thing they want to do, they want to standardize this communication. So they take HTML and create a new standard called XML to help standardize the communication in between different servers. And XML works pretty simply. Let's say you have this kind of document. Let's say you have a user, the name Danny, city Boston, shoe size is 5. You can make a tag that's like, this is a user object. And then you can add subtags saying this is the name, city, shoe size. And then the different servers can just agree on which version of XML, and they had different type systems, they had different core location systems to make it so that you can know which document and which data type was which. But the big difference between HTML, the critical difference, is HTML was a friendly language in that because the web was so chaotic, when web browsers almost always got imperfect HTML, so web browsers had to work with imperfect HTML. So it was a very fuzzy language. Like you could do imperfect HTML, it would still render. XML, on the other hand, was a very strict language. If you did not format the XML correctly and any part incorrectly, it would just simply break. It would just not work. 1 year later, W3C, seeing the chaos of the internet and feeling very confident in XML, create a new standard called XHTML, where they create the rigidity of XML and combine it with HTML with the idea of making the internet easier to work with for automated systems and trying to like make it more uniform. At the same time, they trashed HTML, being like, okay, we're done with HTML. XML is going to supersede HTML, and we're not going to do anything more with HTML. 2000, Netscape is pretty much like extinct at this point. Like the Internet Explorer killed it, and so people take the open source code of Netscape and build Firefox as an open source web browser. They rewrite a bunch of the code, but they take the core of that over. 1 year later, Apple is also sick of Microsoft's bullshit. And so they build their own browser, Safari, specifically because they no longer wanted to pay Microsoft to put Internet Explorer on Mac. So to get around that, they build their own browser. And by 2004, Firefox engineers and Safari engineers look at the W3C's XML standard, and they find it very frustrating. Partially because it is full of bureaucrats that are debating back and forth, so the progress on the specification is really slow, but mainly because XML intends to completely destroy all websites that existed essentially before the 2004. Because all websites that were imperfectly built, which was almost all of them, would be rendered moot using this new standard. So they look at HTML in the trash bin, and they decide, well, if the W3C isn't going to standardize it, we're going to standardize it. So they make a new organization called WHATWIG, which is the Web Hypertext Application Technology Working Group, and they just sort of work together to just create a new version of HTML. 2008, Google starts trying to build more and more dynamic applications on the web, and they get frustrated that the web isn't adapting fast enough for what they need. They want a more fully fledged web so they can deliver a more fully fledged experiences. So this is a couple of years after they do Gmail, and they realize the success of Gmail and like these dynamic styles of apps. So they build a new browser called Chrome. And critically, the core of Chrome, called Chromium, is open source. Because Google realizes that open sourcing software will lead to long-term success of their product, and it gives them control over the internet so they can drive it towards what they need for their products. 2008, WHATWIG finally comes out with the HTML5 specification. And the big thing about the HTML5 specification is that it includes video and other interactive things like canvases and animations. The big thing is that this specification is aimed at trying to knock out Flash, which at this point in time was slow, super insecure, and also full of bugs just from its age. So it wanted a more standardized web experience and to build much more stable, much more reliable applications, and so users no longer had to download Flash. At the same time, W3C is still working on XHTML. They see how good HTML5 looks, so they can XHTML and decide to work with WHATWIG on HTML5, which did not go particularly well. It sort of broke apart really quickly, specifically over the issue of versioning. So Whatwig, being mainly browser manufacturers, wanted the specification to reflect the latest and greatest in browser technology. So they wanted the living standard where the standard would always be updated based off of new things. So you might have a new version every week or every month. It's just whenever they come up with these new expectations, they put it out there. On the other hand, W3C felt it was more appropriate to have a versioned version of HTML. So HTML 5.1, HTML 5.2, with the idea is it allowed website builders to target a specific version number and not have to worry about constantly changing and updating standards. So now the two groups pretty much had two entirely separate standards, where Whatwig published a living standard, where W3C published a version standard. And the way it generally went is that W3C would take snapshots of the living standard and turn it into HTML, but confusingly would tweak some of the standards as they brought it over to HTML5. So if you, at 2012 or beyond, tried to look up HTML standards, you would find yourself very confused at there being multiple standards that sometimes contradicted each other. A couple of years before this, in 2010, we get AngularJS. In 2013, we get React. In 2014, we get Vue. Two of which were big corporations. Vue was made by Randall. And these three applications are going into the theme of trying to build more dynamic websites. Connection speeds have improved. JavaScript has improved to a point where it is now performant, and it is now pretty robust. And now we want to build web applications that are actually interactable. And so we build these frameworks as to manage these more complicated web applications. Additionally, at this point, mobile phones came out in 2008. And so these help us to build more dynamic web applications that can work both on desktop and on mobile. 2015, Microsoft realized Internet Explorer kind of sucks and is pretty much unsalvageable at this point. So they then can Internet Explorer and create a new browser called Edge, which is built from the ground up. It's supposed to be the best browser in the world, and it's supposed to get fast adoption because it's the coolest thing. It's also default on Microsoft, so they're like, okay, we just built a new browser, everything's fine. 4 years later, the market share of Edge is 2%, which is absolutely bloody insane because it's default on the computer. So people have to open Edge to download Chrome.
It's the only time.
It's the only time they open Edge, and it's very clear that people do not care about Edge. And the thing about Edge is that people don't care about it, mainly because they think it's just Internet Explorer in a shell. And also, it costs a lot of money now to build a browser, especially if you're building a private browser, because the standards have become so complicated that it's no longer a trivial task. And Microsoft sort of asked the question, is like, why are we building a browser? And they notice Chrome's open source software being like, hey, we have like 90% of a browser here. Why don't we just take that, make Edge again, but this time with Chrome under the hood. And this is the current version of Edge. Also in 2019, this back and forth between the Whatwig and W3C is becoming like tiresome and confusing. So the W3C finally gives in and gives complete control of the HTML specification to the Whatwig group, where the W3C would still help them with logistics, but the Whatwig group gets to decide the HTML specification. And this pretty much brings us to today, where if you want to go into the web technologies, you have to learn this giant bucket of technology. But the biggest thing that's really fascinating about the web is despite the large impacts of the web, it's still workable, and we still use it to be able to build applications and help people be able to be actionalized and make the kinds of things that they need to do every single day. So that's what I got. Thank you very much. I'm looking for, you can clap. Yes.
A comment and a question. In the period from the 70s and 80s, in addition to the academic and governmental connections, private businesses were deeply involved in this. I worked at DEC through the 80s, and we were doing worldwide projects using our own networking protocols before the web and before the other thing. And many of the early systems ran on DEC equipment and used DEC facilities. The question I have is, you mentioned in Bill Gates' 1995 essay that he saw applications shifting from the desktop operating systems to the web. Did Andreessen and Clark and others see that possibility as well, or was Gates really the one to look over the horizon?
So I don't have any primary resources that say that Andreessen absolutely knew that it was going to web applications. I think that it would be hard pressed to imagine that he didn't see that coming, especially because they invested in JavaScript and Java. So they invested in JavaScript and Java specifically because they saw interaction as being a critical element of the web becoming really popular. I have to imagine like Bill Gates saw this, like the other pioneers probably also saw this, which is also probably the reason why Netscape was really afraid of Microsoft. Because if they didn't think that Microsoft cared, they wouldn't have been doing so many actions specifically to try to get ahead of Microsoft.
Okay, thank you.
Awesome talk. I was like there for large parts of all of this stuff, and from the inside, I had no idea what was going on. Like all these standards were changing, and Netscape came, and then it went away, and all that stuff. So really awesome talk. I liked it just from the history because I'm like, I've been involved forever, but I didn't even realize all the way back in 1969 or whatever, even before I was born. So that was very cool. I'm surprised that you didn't talk about like internet search engines coming out in like I think it was 95, 96, 97. Like what sort of impact that had on all of this spreading. So I love the talk.
So this talk was really painful to make. Like this is like half the notes I had. I had to leave so much on the table, including like I didn't even talk about like the evolution of Angular React Vue because there's a whole like Angular React Vue that was a decades-long adaptation until we get to that point.
Right.
I think part of the difficulty of like the web and trying to tell it as a history is that there's no point where something was made. Because even when I showed like HTML, like the first web page was in 1991, yet HTML was invented in 1992. Like that first web page used HTML. The problem is that HTML was like a gradually built up thing, and that's the case for like most of the web technologies. Right. Is that like even like the search engines, the first one being like Yahoo, where they just had a giant list of links on the web page, and it slowly adapted into like more and more things. It's hard to really stake one thing, and there's so many different actors that influence the direction of the web. That it's my goal here was to just get the highest level thing, but there's so much more interesting stories that like if you dig into it you can find.
Yeah, and one of the things that you pointed out, which I think is a great thing, is like especially at the beginning, like this one person added the image tag.
Yeah.
And it's just they contributed something, it got popular, and like that's one of the things I kind of like about our industry is like if you're at the start of something, you can make these really outsized contributions. And it's just so interesting because the guy that made the thing before it, this grad student or whatever, is just like, I've added the image tag.
Yeah, it's the funny thing. I added the image tag. It's there now.
Yeah.
Yep.
I was thinking something missing from the talk is a discussion of Apache and CDI scripts, which sort of preceded PHP.
Mm-hmm. Yeah, because it's funny because I have a whole bunch of you can sort of see I have a bunch of slides here that are like hidden. From me trying to, because I did the practice talk the other day, and I was like 15 minutes long, so I had to cut some things down. So like there's on top of like the main core technologies, which is what this talk followed, like the core technologies, HTML, CSS, JavaScript. There's also a secondary evolution of sort of like how we serve web pages, how we build web pages, how we build dynamic web pages. And that's an interesting talk because the W3C seems to get it wrong more than right. So W3C standardizes like XML, but then now we're using JSON. Because the general rule of thumb is that if you over-engineer something, the web's going to probably reject it. Yeah. And it's like open source, community-led things that tend to be more successful.
And so the early versions of Mosaic, 93, 94, were often interacting with Perl scripts.
Interesting.
God,
That's,
yeah.
You know what's also really funny about this? I've been spending like the last year and I've interviewed like a dozen people, and I still find interesting tidbits.
Yeah.
So, which is I'm going to quickly segue this, and I still want to ask questions because I think we have like another minute before we have to run out. I'm looking for feedback. I want to do this talk a bunch of other times, so if you can give me feedback on what you liked, what you didn't like, if there's anything you think should be mentioned that I didn't mention, I would absolutely love that feedback. I'm also looking forward to grab coffee chats. I will buy you a coffee if you have experience doing the web. And I literally just want you to rant at me about your experience in the web, because as much as like I'm trying to collect information from the web, what I really want to express is sort of like what it felt like being through these kinds of changes. And the only way I can do that is by talking to people.
I had a question. So is the current status, what you're saying is that the LS version of HTML is that there's not a standard?
It's the living standard is the main standard. So you can go
It's
on.
an constantly evolving standard.
Yeah, it's a constantly evolving standard. Like I can go on my browser and they probably just update. It's actually really funny how often it gets updated. Yeah, so it was literally last updated, what, yesterday? 2 days ago? So this is the actual, and you can see this is Whatwig's website. This is the actual official standard for HTML. Like you as a developer would never want to look at this. You would actually go to like MDN. That's more for like developer facing, but this is meant for browser manufacturers mainly to help make sure that the browsers are more or less interoperable.
Yeah, I mean, as you said, you have limited time, but it would be interesting to also sort of mention a lot of the losers along the way. Because I would disagree that Yahoo was a browser. I mean, a
Search engine?
a search engine. It was
Directory.
basically a directory.
Yeah, it was a directory.
You know, and then you've got things like AOL, which was like really popular, made lots of money, bought, you know,
Got mail.
Warner Brothers and a bunch of other things. It was $1 billion company or billions of dollars company, and it was basically a walled garden version of the World Wide Web.
But you also have CompuServe, which is another like example of like a walled garden. So like I actually want to do a presentation where it's just a losers presentation. Just go over the entire history of everything that was wrong. It was really funny because often you hear about history in terms of the winners, and like this is an example of that, and that's useful. But it's almost just as if not more useful to figure out what didn't work than what did work. The trouble is just figuring out what didn't work can be really challenging to find that information. So I do want to go back and make another entire presentation just going over losers.
So many AOL disks in landfills.
Yeah.
If I remember correctly, when Chrome first came out, one of its big advantages was that Google had re-implemented JavaScript and it actually ran quickly.
Yes, it's their V8 engine was a big thing with Chrome. So like up till Chrome, JavaScript was slow. They built a V8 engine which actually made JavaScript quick, surprisingly quick. And that was a big advantage. And then that also created Node.js, which was used now on the server side. So again, another big irony of the web is like Java and JavaScript. JavaScript was this toy language that is now the most popular language in the world and is used on the server, it's used on the client, it's used everywhere.
And it's helped Bill Gates' nightmare come true.
Yeah, it helped Bill Gates' nightmare come true. Awesome. Thank you so much, everybody. If you have any questions, you can always contact me. My contact information is also in that QR code as well if you need to get in touch with me.
All right. Awesome. Thank you.